Hello, welcome to the Periodic Trends podcast. In class, I discussed three different ways in which elements are classified on the periodic table. As you could see up on this periodic table, all the elements in green are your metals. Don't confuse yourself with hydrogen. Hydrogen may be on the metal side of the periodic table, but it's the only exception. Hydrogen is actually a nonmetal. We also talked about the semi-metals in purple. You would draw a little ladder like this. All the elements touching the ladder, with the exception of aluminum and polonium, are semi-metals. On this side in orange, you have your nonmetals. So there are three ways to classify them. You could classify elements by metals, nonmetals, or semi-metals. We also talked about groups or families, like group 1A corresponds to the alkali metals, group 7 the halogens, group 8 corresponds to the noble gases. And the third way that we organize elements is by increasing atomic number, which also represents the number of protons. Remember, even though it looks like elements increase by mass, there are exceptions. For example, cobalt and nickel. Um, if you go to the right, from cobalt to nickel, the mass actually goes down. So we do not say that elements are classified by increasing mass. We don't say that. That's not true. But they do increase by atomic number. We also talked about the properties of metals. Metals are good conductors, meaning that they are really good at transferring heat and electricity. Okay, so they're shiny, they're malleable, meaning that you could change them. You could change forms. We also talked about non-metals. This is not written in your notes, so I asked students to write this first point right here on their notes. So non-metals are poor conductors. That means they do not transfer heat. So if I heat up one piece of the sulfur, you're not going to feel the heat on the other side of the sulfur because it doesn't transfer any heat. Therefore, they're not called conductors, they're called insulators. Okay, if I heat up the tip of this pencil, you're not going to feel the heat on the other side because they don't conduct electricity, they're insulators. Okay, styrofoam, for example, is an insulator. It's made up of nonmetals. Plastics are made up of nonmetals. Now, semi-metals are found right in between the metals and the non-metals, and you were asked to draw this little ladder on the periodic table found in 13R. All the elements touching the ladder, with the exception of aluminum and polonium, are your semi-metals. So they have properties that are found in between metals and non-metals. They're okay conductors of electricity, but they're not good at it. They're like in between. So that's why they're called semi-metals or metalloids. It's another name for semi-metals. So we didn't talk about this. We went straight into this slide right here. This is something that you have to memorize. Okay, you have to memorize this little box. This little box represents the periodic table. As you move from the right side to the left side, the atomic size gets bigger. The size of the atom gets bigger as you move from the right to the left, and from top to bottom, the size of the atom goes up. As you move to the right of the periodic table and up the periodic table, ionization energy and electronegativity goes up. And we'll talk more about that in a bit. So if you look at this PowerPoint slide, we talked about this in class and we talked about it with each other as elbow partners. We said that as you move to the right, from lithium to beryllium to boron to carbon, you're adding more protons, but why is it that the atom is shrinking? Why? Why is the atom shrinking? So if you want to pause this and think about that, go ahead and do that. The answer is this. The reason why, even though you're moving to the right and even though you're adding more protons, The reason why the atom is shrinking is because as you add more protons, there's more positive charge in the nucleus. As you add more positive charge in the nucleus, it's going to attract the electrons even more. It's going to pull on the electrons towards itself, shrinking the atom. Okay, it shrinks the atom. As there's more positive charge in the middle, it pulls on the negative charged electrons because opposites attract. It brings them in and it causes the atom to shrink. But going down the periodic table, even though you're adding more protons, the atoms get bigger. And the reason why is because there's more electron clouds, there's more orbits um, around the atom. So the electrons that are on the inside are shielding the positive charge in which the nucleus is attracting the electrons on the outer side. So the atom tends to get bigger as you move down. So what I just said is right here. What I just said is right here. So you could just look at the PowerPoint slides, which are found on my website. For honors, we talked about this. So if you're in honors, this is for honors. If you have a positive charge, that means that you lost an electron. And if you lose electrons, that means you're going to have a smaller atom, or ion in this case. So that's why it shrinks. But if you gain electron, like fluorine gains an electron to become stable, it gets bigger because the more electrons you have, the bigger you get as an ion compared to its neutral form. Now, we also talked about ionization energy, so this is for both regular and chemistry honors. Ionization energy is the amount of energy needed to remove an electron. So you can't just pluck an electron out. Like fluorine wants an extra electron, right? So if fluorine wants to steal an electron, you need a you need a lot of ionization energy to get rid of an electron. Okay, for example, lithium has one valence electron right here. Lithium has one valence electron. It wants to get rid of that electron to become stable. Therefore, a good, uh, it's gonna need a small amount of, it's gonna need a large amount of ionization energy to get rid of that one electron. Okay, so we talked about ordering the elements from smallest to largest ionization energy. So you had to draw this. You have to think of this. So you have to look at the ionization energy going to the right and up. There's an increase in ionization energy. So here lithium, but cesium and potassium. So let's see, let's get rid of this guy right here. Right here, cesium is right here in 55, potassium is right here, and lithium's right here. I told you guys as you move to the right and up the periodic table, ionization energy goes up. So the one with the smallest ionization energy would be cesium, then potassium, and then lithium. So that would be the answer to this question. Order the elements from smallest to largest ionization energy. Okay, so first it'll be cesium because it's at the bottom, then potassium, and then lithium. And then this one is going across the periodic table, fluorine, carbon, and oxygen. So fluorine's right here, carbon's right here, and oxygen's right here. So moving to the right, ionization energy increases. So you're gonna have um, carbon with the smallest ionization energy, then oxygen, and then fluorine. So that would be your answer to that question. Um, in class, we did a puzzle. You had to organize the little people by patterns. You had to think just how Mendeleev was thinking when he was putting the periodic table together. So um, that's what he was. That's what he was doing. That's what the students were doing in class. They were trying to organize the people, and they tried to draw the missing person. So if you have that handout, make sure you look at it. We also read a Scientific American article. Um, so the article is found on my website, and the discussion board is right here. So make sure you have that posted because that will be graded. And that's where we left off. The last thing I want to talk about is electronegativity. Electronegativity is the atom attracting the amount of attractiveness that the atom has towards the electrons. So the more you're attracted to something, the higher the electronegativity. For example, I have a higher electronegativity for the hot Cheetos because I'd rather eat hot Cheetos than the piece of lettuce. Okay, so my electronegativity is high with respect to the hot Cheetos. Electronegativity is the measure of the ability of an atom to attract its electrons. So I am more attracted to the hot Cheetos. As you go to the right and up the periodic table, electronegativity goes up. Fluorine has the highest electronegativity. We said that noble gases are already stable, so they don't have any ionization energy. They don't have any electronegativity. The one with the highest electronegativity is fluorine. That means fluorine really pulls on those electrons. It really wants to hold on to it. It won't let go easily. And because it has a high electronegativity, it's going to need a lot of energy to get rid of an electron. So fluorine doesn't want to let go of those electrons. That's why it has a high electronegativity. And because it has a high electronegativity, it's going to have a high ionization energy as well because it's harder to pull away those electrons. Therefore, it's going to need a lot more ionization energy. Okay, so that's the relationship between the two. Now, as you go down a group, we talked about this before, you are adding more layers, more orbits, right? So as you're going down the periodic table, electronegativity goes down because of the shielding effect. There are so many electrons everywhere that it's hard for the nucleus to attract those outer electrons. So the electrons that are in the middle are shielding those outer electrons from being pulled into the nucleus. And that is why as you go down the periodic table, electronegativity goes down. As you move to the right, you're adding more protons. The more protons you add, the more the nucleus pulls on those outer electrons. So that's why as you move to the right side of the periodic table, electronegativity goes up because it has more positive charge. It's attracting, it's pulling on the electrons even more towards itself. So if you were to rank these elements from smallest to largest electronegativity, you'd first go to the periodic table right here. So we're looking at oxygen, beryllium, and lithium. So oxygen is right here, beryllium is right here, and lithium is right here. So as you move to the right, electronegativity goes up. So lithium would have a low one, then beryllium would have a higher electronegativity, and then finally carbon and all of these elements would have higher electronegativity. So first it would be lithium, then beryllium, and then oxygen would have the highest. And I think you could do this one. Remember, fluorine is the most electronegative. So going up the periodic table, there's more electronegativity. There's more of the nucleus pulling on those outer electrons. So don't forget to memorize this. This is very important. You have to memorize this. Okay. Good luck. Hope this podcast was very helpful.